Okay, so now we're on to question 6. All right, so question 6 has us solve equations. And before we can solve an equation, an exponential equation, this is an exponential equation because the variable's in the power. This one's a logarithmic equation because it's got a log in it. This one's an exponential and this one's a log. So we're going to go and try and solve each one of these. So if you've got a single exponential function, so this is single, it's on its own, there's only one of them. What kills base e but natural log? So I'm going to natural log everything. So you ready? Natural log of e, that kills itself off, and we're left with 4x. So whatever I do to one side, I do to the other, right? So natural log of e to the 4x gives me 4x, and then I do natural log of 1,000. Okay, and now I just divide both sides by 4, and I get x equals ln of 1,000 divided by 4, and you can type that into your calculator. Now be aware that Lisa and I might actually have you leave it in exact form. So if it says leave in exact form, you leave it like this, and that actually helps you because you don't have to key stuff into a calculator. So that's part A. Now part B. This one right here has 10 exponential functions. So before I do anything, I need to divide both sides by 10. And that's going to give me 5 to the 2x equals 300. And now I'm going to hit it with a logarithm. Now, what logarithm is the easiest one to hit with it? The easiest one is the log base 5 one. So that's what I'm going to do. So if I hit log base 5, that's going to kill the 5 off, left me with 2x equals log base 5 of 300, and then I just divide both sides by 2. So my answer, I'm sorry, there's not much room here, is there? My answer is going to be x equals log base 5 of 300 divided by 2. And if it asked you for an exact answer, you'd leave it like this. And if it asked you for an estimate, or rounding it to 2 decimal places, or 3 or whatever, you'd have to key it into your calculator. We good? Good. Now we're going to move on to C. So this is a logarithm equation. So the first thing we need to do is get that log on its own. It's got that 2 with it. I don't like it, and that 2 is being added to it. So we're going to subtract both sides by 2. So if I subtract both sides by 2, I get log 4x equals 3. I subtracted 2. All right, good. Now, what kills a logarithm? An exponent. So what is the base of my logarithm? Oh, it doesn't say, but it must be 10. And so what I'm going to do is I'm going to put a little 10 down here and a little 10 down there. And that says 10 raised to the log base 10 in the up here, right? Those are inverse properties. These will cancel each other out and leave me with 4x equals 10 to the 3. Now 10 to the 3 is 1,000, and then we just divide both sides by 4, and we get 10,000 divided by, 1,000 divided by 4. Good? And we can leave that, simplify it, whatever, you're fine with that. We good? All right, so now we're going to move on to the last problem. Now, we can't hit this with an exponent until it's a single thingy, a single logarithm, and it's not, it's got 2. But we know from up here that we can take 2 logarithms and make them 1 if they're being added by using the product property. So that's going to give me log 3 18x equals 1. Now, what's the base of that logarithm? Oh yes, it's 3. So if I put a little 3 down here and a little 3 down here, 3 log 3 of 18x is going to give me 18x. They'll cancel each other off. And 3 to the 1 is not 3. 3 to the 1 is 3 to the 1 is 3. I'm old. Now we're going to divide both sides by 18. So divide both sides by 18, and we'll get x equals 1/6. Okay. And that is question